So now let's take a look at stream crossing analysis and design. So in this scenario, our goal here is to calculate the flow and design a culvert for a stream crossing. So in doing this, you're going to need to be pretty up on your hydrology, and we want the software to be able to do that as well. We don't want just, again, a pretty picture. We want the software to incorporate, hydrology methods and logical calculations to determine the flow for us. And also, again, keep in mind engineering concepts to accept and adhere to slope and elevation. So again, how long would it take you or your staff to accomplish that, and what skills would it require? So again, we'll do a side-by-side comparison, where in Civil 3D it looks like it's roughly about 6 steps, and in InfraWorks we can usually accomplish that in about 4. So in doing it with Civil 3D, typically what you're going to do is you're going to identify a culvert location, and then with Civil 3D you can create a catchment area, or a catchment object if you will, and then you're going to want to transfer that data out. So maybe utilizing HydroFlow, which is included with Civil 3D, or maybe you have your own product that you prefer to use. So then what you would then do is you put in the known values, or even some assumed ones, and try and determine some basic information about that pipe. Now, once you have enough information, you've got your coefficients and things like that in there, you'll then come back to your Civil 3D file. And then you'll start kind of roughing out where that pipe's going to go. From there you can pull some surface elevations, and then from your line you might be able to get the length on that. You'll then come back to your water analysis program, and then you'll put in the results of what you found out in Civil 3D. So you'll plug in elevations, you'll plug in the pipe length, initial sizes, things like that, and kind of get an understanding of what it's going to take from that product to generate that pipe and make sure it's not going to overflow and everything else. And then once you have that done, then you'll take it back into Civil 3D, and then from that line or the initial layout you've done, you'll then generate a pipe, and you can then generate the head walls or the end caps or whatever else you're going to be putting in there to finalize that design. Again, great detailed design, but possibly a little more than needed at this point in time. So it looks like InfraWorks is off and running now. Civil 3D is still going. Looks like it's about 7 minutes in. And in InfraWorks, it's basically 4 steps. So first thing you do is you select your project, select your surface, and choose Create Watersheds. It'll automatically generate the watersheds that are required. And then you can choose the Create Culverts command, where it'll go through and generate the culverts. And then once that's been done, you can say calculate the watershed flow. And then finally, once it calculates it, all you do is really click on the culvert object that's been placed, and it'll automatically resize that culvert with those values. So the end result in Civil 3D, what you get is a very, very detailed, really final culvert design, which is great if, again, if nothing changes and that's exactly what you wanted, a lot of the work's done. However, in InfraWorks, when you get done, you'll have a very detailed culvert design in context, all in one location, one software to develop everything. It was very quick, and it's contained within the Civil 3D, the 3D surroundings of the landscape and all of the surrounding areas. That's kind of nice. So again, I recognize that that went a little bit quick, so let's take a look at that again, a little bit more refined. So again, you just kind of click on your area. In this case, we're going to have it actually run the road surface itself. So in this case, click on the road, choose Create Watersheds, and what it's going to do is it's going to analyze the terrain, and it's going to analyze the location of the roadway. It's going to look for where streams might be crossing underneath the road, and basically just generate those catchment areas, if you will. So in this case, you can see it looks like it came with about 3, and you can see it flagged where each one of these catchment areas or stream crossings are going to occur within our roadway. So then we can just choose the Add Culverts tool, and it's going to go through, process that, find the low points, align them. And then one of the nice things too is even if on the inlets, the little head walls that you're putting on there, it does orient those that way as well, so that they're lined up with the pipes. And from there, once those get placed in there, we can say calculate watershed flow, and we can put in a couple different methods. We need to place our location and the type of calculation we want to use for the analysis, and let it run the analysis. And again, at that point, all you have to really do is just simply click on that pipe, and it will resize the pipe with the capacity. And one of the nice things that you can see right here on the screen now is you actually get a nice 3D exhibit or representation, if you will, of what the final output was on this. So not only do you just get the pipe in there and sized, again, you can actually look at it and you can see a 3D visual of how that pipe's going to perform, what capacity it's going to be at, as well as data that's representing the downstream, upstream information regarding that pipe as well, which is really nice to be able to demonstrate the intent of what you've placed in your model. So again, once you kind of get that to the point that you're happy with it and you're ready to move forward with your design, again, this is where Civil 3D would step in and take over the detailed design work, further refine that. You can then come back, and if you want to rerun it through something like HydroFlow or something to get the actual hard numbers and generate the reports that might be required with your submittal, you could do that there. And that's where Civil 3D really shines, gives you the ability to be able to do that. So again, a quick breakdown of where we stand right now. Civil 3D by itself, it was a very meticulous, detailed process, and with the Civil 3D InfraWorks combination, it was about 4 steps. And with Civil 3D, again, you really needed a strong skill set to be able to do that with those 2 products. And then in InfraWorks, we were able to do it pretty quickly with only a couple clicks. And then again, with Civil 3D, it did require you to go to a second product and manually transfer the information from product to product, where in InfraWorks, it was all done in one location. In Civil 3D, again, everything was hard numbers, everything, there was no assumptions, you had full control over your design. Where in InfraWorks, there were some assumptions made, but again, it's a preliminary phase, so we just, the intent here is to get the design in, get it in quickly, and get something logical back, so we have good feedback on what our conditions may be. And then the final result, in Civil 3D, you do have a detailed culvert design, and you're pretty much ready for documentation. And then in InfraWorks, you got a detailed culvert design, you do have documentation, but you've also got a 3D model in context of the surrounding area and a 3D graphical analysis of the culvert and its performance. So that's kind of nice also.